Alright, hi you guys, and today we'll be talking about the Pythagorean theorem. Okay, now Pythagorean theorem actually comes from some old school math of just working with a certain type of right triangle. Well, actually any type of right triangle. That's the beautiful thing about it. Okay, so some spots to start defining. Okay, so this is the hypotenuse. Hypotenuse. There we go. And that makes these two the legs. So that's a leg and that's a leg. Okay. Now how can I tell the hypotenuse apart from the legs? Well, the hypotenuse is always going to be opposite of the right angle. So something pretty as simple as that. Okay, and the legs are always going to be adjacent to the right angle. Okay, so there's our couple of definitions right there. Now here's the cool thing about the Pythagorean theorem. Okay, Pythagorean theorem, C is always the hypotenuse and A and B are always the legs, and because you can't tell the difference between them, it doesn't matter which order you go. But the actual definition of the Pythagorean theorem is if you take the square of one leg and then add it with the square of the other leg, it should equal the square of the hypotenuse. Okay, so in other words, whatever number this is, I square it, plus whatever number this is, I square it, and then, or well, actually, whatever number squared here, add them, and then it should equal this squared. Okay, and there's actually a really cool proof that comes about because of this. Alright, so if we actually set out, you can actually draw this proof. So take any three squares. I'll take the usuals that are pretty darn easy to draw. Okay, so let's say that you have one square that is 9 feet squared. Let's say you have another square that is 16 feet squared. Okay, I know it's not exactly, it's not bigger than the other one, but just give me a break. The screen only goes that far. So this is 16 feet squared. Alright, but then here's the cool thing is that if we finish off and we keep this a right angle between the two, if we finish this off with the third side of the square, okay, like this, and once again, not exactly the best drawing in the world, but it actually works out pretty darn well. This will be 25 feet squared. Okay, and this is the really cool thing, because if you notice, 9 plus 16 equals 25, which is the two squares areas that actually add up, and that's a proof, and this is your actual triangle in here. So this is your triangle in here that you're actually dealing with, that you actually made out of three squares. Okay, and that's where the idea of squaring actually comes from. Okay. Some really cool stuff that you can actually do. Now, obviously, this is all set up to find C, okay? But what if you need A or B? Well, just minus to the other side. So, for example, if I wanted B squared, it would be C squared minus A squared. Or if I wanted A squared, it would equal C squared minus B squared. So you could set it up, the Pythagorean theorem, to have a couple other ideas behind it, okay? Alright, now let's go ahead and practice some of them. Alright, so let's say that we knew two sides of a triangle were 5 and 13. Okay, and we knew it was a right triangle. Alright, so what we could do is we could actually solve for this missing third side, which would be C. We would just go set it into our formula. 5 squared plus 13 squared is equal to C squared. Okay, the 5 squared is going to be 25 plus 169, which is 13 squared, equals C squared. Okay, then I add those two together. Let me check my math. I don't want to add them and then give you the wrong part. 194 is equal to C squared. Okay, now if you remember in your toolbox of solving, if I square root both sides, .9, let's say 3 is an approximation of what's going on there. Okay. All right, so we've got this all set up like this, and it's just as simple as that. You're just going to get something that works like this. Now, majority of the time, they'll probably just ask you for the approximation, but if you can leave it just as the square root, we'll talk more about that in a little bit, about how to simplify something that looks like this. But for right now, we'll actually just stick with the approximation just to get through it. Okay. All right. Now, there are some other statements, if you remember from the last slide. Conclusion, conditional, converse, and hypothesis. Okay. All right. So let's start talking a little bit about actual working with this. Okay. So conditional statement is a statement that is if something, then something happens. Okay, so that's what that statement is. Now this first something we will actually call the hypothesis. Oops. Hypothesis. Okay, and then this second something, the something that happens, is actually what we would call conclusion. Okay. Now, what a converse is it switches those two orders. Okay, so converse is if I switch these two. So that's what we would call a converse. Now, a converse, usually, like for example, the Pythagorean theorem is if you have a right triangle, you can say that a squared plus b squared equals c squared. Okay, so our hypothesis is if you have a right triangle, and I technically should typed in then. There we go. Okay, so our hypothesis would actually be if you have a right triangle, then you can say that a squared plus b squared equals c squared. Let me go back to change that part. That would actually be our conclusion. Okay, so if we wanted to do the converse of that, the converse would be if a squared plus b squared equals c squared in a triangle, then you have a right triangle. Okay. All right. And that's the really cool thing about conditionals and converses. Now, sometimes the conditional will be true going one way, so in other words, from hypothesis to conclusion, but then sometimes when you do the converse, it's not exactly true, but this is always true. Okay, and same thing here for the actual original Pythagorean theorem statement. So this will always be true too. Okay, now what we're going to be talking about next is what happens when we want to deal with these square roots and we just want to mess around with them, okay? Before we get there, sorry, let me go back to the actual converse. So in other words, if you are given a list of 3 numbers and you wanted to see like 6, 24, and 25, and you were wondering if they're Pythagorean pair or Pythagorean triple, in other words, this was the sides of a Pythagorean triangle, you would just go 6 squared plus 24 squared. Go back and see if that equals 25 squared. Okay, and so this is going to be 36. So this would be 36 plus 576, and that should equal 625. All right, but as you can see, that's definitely not going to equal 625. So we're going to say that that is not equal. And this is how you write in long form, not equal. You write 2 equal signs with a slash between them. It looks like a non-equal sign. Okay, so this is a big fat no right there. Okay. When working with Pythagorean theorems, remember that you can find either one of the legs or just the hypotenuse and just work your way across. But that's Pythagorean theorem for you guys, and here's a cool little gift, a cool little reminder on how to actually prove Pythagorean theorem. Thank you very much, and have a great day. Bye.